My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired.
Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GlowCloud team.
Welcome, everyone. I am here as Mike Gibbs. I am joined by Russ White, and today we're here to have a conversation about the history of architecture careers, for example, where we started, Russ White and I, maybe 25 years ago, the kind of constraints that Russ and I actually had in those days, just getting things to work and making sure that we had the features and the functionalities necessary to build out the internet. And we're going to talk about how the tech has changed. At least that was the plan. And then we'll talk about why that impacted the architecture roles for today. How when we went from being the design and the tech experts to figuring out how to make this stuff to work, to being the people we are now in order to help businesses actually gain a financial return on their investment from technology. And while we're at it, we may touch on the two paths that you could take your architecture career. You could take it down the distinguished architecture path, which Russ did. And that's a great path for the people that want to focus on certain components like being an industry leader. And of course, we'll talk about the exact opposite that you can also talk about in your architecture career, which is more the enterprise architect or the architect who focuses more on the business things. And then you'll see the similarities between what you see out of top level architects, whether they're principal architects and distinguished architects, as well as what you see in enterprise architects, because in a lot of the ways, they're very similar. So if you don't know Russ White, Russ is an icon in the world of networking. You know, all of us grew up reading his books. He was the distinguished architect at Cisco. To put that into context, we had about 80,000 people and about 350 comprised the distinguished architect team. So not many. And so Russ is someone I always want to listen to. He's got some great books that are out there. He's got some great training. And
I don't know. Really, you shouldn't listen to me, Mike. I'm sorry, but go ahead.
So it's been a long time. Welcome, Russ White. How are you today?
Good, fine. I don't know. You built me up. Now I may have to go on mute and disappear because I don't know if I can live up to that billing, but cool.
I've been reading your books forever, and we all work together at Cisco. So Russ, I want to talk about the beginning world of networking, what I consider to be that 1995 to 2003 range where we were really trying to build out the network. And in those days, I was more on the technical architect side like you. And for the most part, for me, getting things to work was really the challenge. Having the routers that may have had 8 megabytes of DRAM in them, having 15 and 25 megahertz CPUs, having boxes that were so limited that if we took too many routes into the network, everything would just break. If we didn't know where to aggregate things, things would just break. If we didn't have perfect design, once we get above a few sites, it was going to break. Russ, what was your experience? I was at Riverstone Networks doing that. I was at WorldCom trying to build out the future of the internet.
Yeah, it was the same thing at Cisco. I mean, the CCIE was primarily, the lab was primarily oh, let's go like push in. I don't know if you remember the 60-pin cables that we used to have for HDLC. And the lab was actually push-in cables and the 60-pin connector so it wouldn't completely fit. And so you push the cable in, you wouldn't get a good connection. So you get carrier, but you wouldn't get signal or something like that. And there were all sorts of weird problems we faced in the real world. Like, I don't know. I remember doing huge, well, at the time, huge 300, 400 hub and spoke networks using EIGRP. And we would actually throw hardware at the problem. We would add layers of routers to make it work because it was so hard to get things to work. And all the plugging, the dip switches were actually, they weren't dip switches, they were jumpers on the AGS Plus and those, the CGS and the MGS, and making it boot. And then like, oh, wait a minute. My config file has gotten too large. My image is too large. I've got a TFTP boot. So now I've got to like, okay, figure out how to set the dip switches or the jumpers to boot to the local memory just to get to the TFTP box. And then, that was all a big mess. That was a lot of it was just, like you said, just getting things to work. Like it just took hours to make things work. And we don't seem to be there today. Well, not all the time. Sometimes, but not all the time.
But the constraints were so much. And what Russ is describing was the routers could only hold so many routes, especially with EIGRP. And what would happen if the routers would get busy processing traffic or got too many messages or one too many links went up and down, the routers would have to recalculate them. And what would happen is the CPU would hit 100%, EIGRP would hit this thing called stuck inactive, and then everything would restart, and then they'd all try to reconverge again, and they would all crash and reboot. And we had the same thing with OSPF when our databases. So it was all, can we make this totally stubby? Can we make this not so stubby? Can we aggregate and summarize to the core? So the reason I'm bringing this up was for the first architects like us, like Russ and I then, when it was my principal architect job and his initial roles, we were technical then. Deeply technical. And I'd say we weren't really even architects at all. We were more design engineers or technical architects in those days, because in those days, they were coming to us as the wizards that could figure out a strategy to make it work.
Yep. Yeah. I mean, I remember working on a bank network that went down, and the bank came to us and said, we want you to design a network that will never fail again. And like, that was a huge challenge. I mean, even getting to 3 and 4 nines or even 2 nines in those days was incredible. So we designed this whole thing with dual cores using 2 different Cisco boxes with 2 different operating systems, 2 different routing protocols connected via BGP, and like this whole thing so that a single bug in any routing protocol could not cause the network to fail. It was this huge hardware problem and all these circuits all over the place. And because we didn't really have, most of the work that we were doing was design and stuff like that, because we weren't dealing, the business was throwing requirements over the wall. We were trying to fix them. We had no feedback loop. We were not pushing back on the businesses at all. Zero, zilch, nothing. And, it's a different world now. I think it's a different world now.
It's a very different world, but I think some people try to take their architect careers in the wrong direction because they're thinking of what it was 25 years ago. And then around 2003, I heard one of the greatest tech leaders, who I'm faking, but I'm not going to mention his name. And he actually said, we've only wanted to sell our products to smart people, but there's not enough of them in the world, so we need to make our products simpler and easier to understand. And I know you know what I mean.
No,
And right after that, there was an effort to make things simpler. And now it was all of a sudden, now we got the tech to work. Now, how do we get some business value out of the tech? How does that tech drive transformation in our business? And I'd say those next set of architects from, say, 2003 to maybe 2010, that's when the architects needed to start developing business skills, CXO relevancy, the business acumen to understand the business, to be able to say, this is not going to help your business. I recommend this versus this. That's when we started getting in the business of evaluating trade-offs and opportunity. That's when we started presenting at conferences constantly and writing thought leadership documents. And I don't know about you, Russ, one of the things that I was doing was building groups where we were getting feedback from like CIOs and CTOs of the kind of things they were going to need in the future. So then we could go work with the product teams to go develop the products and features. And I bet you did the same thing.
Yeah. As a matter of fact, my role at Cisco switched from being very technical, like down in the dirt, to much more go talk to customers, help them design their network, and then see the pain points for yourself. What is it they're facing on the business end that's causing them problems? And then let's figure out how we build product to get around those problems. So those problems just don't exist any longer. That was like a lot of my job for like 10 years. And that's, I think, how I made the transition from being very much about connectors and configurations, the C's and C's, speeds and feeds, up to what is the business trying to get done here? How do we add value to the business? And even furthermore, how do I tell the business, stop doing this? Because I don't care how much you do of that. I can't add value when you do that. You're not putting me in a position as a technical person to be able to go solve any real problems for you. So yeah, that I think is where the transition happened, was in that time frame.
Yeah, and when that transition happened, there was a new archetype for the actual architect. Now all of a sudden, it wasn't like you were looking for the person that was going to be staring at code all day. In most cases, we weren't going to touch the technology anyway. But we had to evaluate all the business problems, and we had to evaluate the way the business operated, looking at their business architecture for the process. Because if we were going to design a good architecture, it had to support the optimal business process. And then we were starting building teams to baseline organizations and see what their tech was. And then we were taking that same team, and it was a big team to try to create the right design. Now we were giving more presentations to the board. Now I know Russ and I did a whole lot of executive briefings and executive briefing centers. Now we were out there talking with big C-suite people of various internet service providers, various CEOs of banks and CIOs and CTOs. And then it became, in my mind, more of an executive role with a strong technology knowledge that was needed to get there. Did you sense that trend yourself? But you also stayed in the distinguished side. So I want to talk about the differences between it.
Yeah. And I've stayed much more technical than a lot of people who have gone straight up architecture roles. Although I'm still classified as a senior architect at the company I'm at now, which is Akamai. So I'm still a senior architect at Akamai, and I've always played an architect role, but it's still more, I'd still do a lot more technology than a lot of people who do architect roles. Partially that's just because it's my background. I mean, I did electronic engineering for years and years, and then jumped into computer networks, and I've just always done it. Partially that's because I still think that there is a level between the business side and the technology side that you not just only need to be able to speak the language of technology, but you actually need to know. Like, I've sat in meetings, and this drives me nuts, where I've had an architect explain how something works and they explain it wrong. And it's not wrong in a way that's going to hurt the customer necessarily, but it's still maddening. Like, you just want to sit in the back of the room and say, stop, just stop right where you are. Let me have the whiteboard. Just sit down, because like, what you're doing here is you're not really explaining how this technology works accurately. And there are many times when I'm in a situation as well where I'll see people and they'll say, well, let's deploy this. And you're like, okay, what are the technical trade-offs? What are you going to cause when you do this? And they don't know the technology well enough to say, oh, if I do this, that causes that. Even if you explain it to them, they're like, wait, but that's not true. And you're like, yeah, it is true. I've been doing this for a long time. That is what's going to happen. And they just don't even understand enough of the technology. So I've stayed much more technical than most of the people who've moved into more architecture roles have over the years. But that's also personal. I have a lot of range. That's just like a thing with me. And so, you know.
And you're also dealing with someone that's got multiple master's degrees, PhDs, that just loves to learn things. But there is going to be at some point a bifurcation where you can go versus the enterprise architect versus the distinguished architect. But two things: the distinguished architect is always a tech leader. A distinguished architect like Russ has patents. He's got things that he's done with the Internet Engineering Task Force, potentially the IEEE. If there's a time to go speak at NANOG or something, he's going to be there. So there's that. But I completely agree with Russ that the architect needs to know how the technology works. I don't care so much if they know how to configure it, the scripts like that, but I need them to understand. And that's one of the reasons, for example, we have 1,000 hours in our training. And, when we talk BGP, I don't just describe BGP, and I don't just teach about the BGP finite state machine, and I don't just teach about the BGP messages. I teach about the attributes, and we teach about how you would perform traffic engineering, how you would filter, and the why. So we're talking all about the protocol. Because if you're going to be a cloud architect, for example, and you're going to deal with cloud networking, you need to know BGP. You're also still going to need IP addressing, subnetting, supernetting, route aggregation, because if not, things are going to fall apart. You're going to know what kind of wide area network to connect. You're going to have to understand switching and switching constraints and switching challenges and things like link aggregation groups. You don't have to build them. I don't care if you touch the technology ever in your life, but you need to be able to see what goes on. You need to be able to see that IP address plan and how it's going to spread out to your organization. And what you really need to know is how the pieces and parts work together. Because if you don't, you can't evaluate what's going to happen, the ifs and the whens. And I actually agree with Russ so much that, and at some point I want to talk about the enterprise versus the distinguished architect, because they're basically the two ways you could take your career. But in our enterprise architect program, if you hear me describe it, you hear me say, look, here's our enterprise architect program, but we also include you in the cloud architect classes. And here's the reason. Because once we start getting to most of these executive architects, they don't actually understand how the technology works. And if you don't understand how the technology works, which you can't learn by doing labs, by the way, you can do labs all day long and projects all day long, and you're not going to learn anything from it by typing config T on a router. You're going to learn it by learning these protocols and understanding it and reading the RFC. Yep. And heck, if you're one of those people, I didn't need it, that took a sniffer and watched all these things along the way, it's how it works versus why it works.
Yeah.
I mean,
yeah. And in fact, reading the code, I'll even go so far as to read the code. Like I prefer to read the code more than I do reading the RFCs. That sounds crazy to people, but the code, if the code is a correct interpretation of the RFC, which isn't always true, but if it is, it's actually easier in many cases to read the code and look and see, I get this, that's going to happen, that's going to happen, this is going to be the cause of that, this timer's going to kick off, that's going to happen. If I read the RFC, all of a sudden I have all this like, okay, that's in Appendix 14, Section 3, subsection A, you've got to go read that and come back, and then you got to understand how this fits into that, and oh, that packet format's described over here, and it's like, no, I can just read the code. I can see the data structures. The data structures are directly correlated to the packet formats. It's there. It's right there as long as it's good implementation. Again, there's going to be differentials, but that's just the way of.
And you're referring to the routing code, right?
Yeah. Oh, yeah. Routing code mostly. Yeah. Switching code is typically not. Switching code is not typically something you're going to get. Like even Broadcom's code for switching on their interfaces and stuff, you're not going to get your hands on that. So Raja asked there in the comments, where do you get that code? Well, easy enough. Go grab the FR routing project. You can run GitHub on your desktop, download the project code. You have OSPF, ISIS, OSPF v3, OSPF v2, RIP. If you ever, who the heck wants to use RIP? A quasi implementation of EDGE Europe, in fact, if you want to. And other places, you can grab the Bird code, and Bird has BGP. And if you're not comfortable with C, you can go get Go BGP or BGP Rust. Now, those aren't as full of implementations as something like FR routing or Bird. FR routing is the most complete implementation of BGP in open source. So, it's possible. You just go grab that code, and if you know C well enough to muddle your way through it, not to write it, just to read it, which is a different problem. Don't get trapped in thinking you have to learn to write C in order to be able to read it. It's much easier to read than it is to write in many cases. But again, this is just like a personal preference for me. I know C, I've known it for years. I can just go grab the code. I walk around with a full implementation of BGP on my laptop all the time.
You know, it's actually interesting. I'm the guy that reads the RFCs or reads the books, but whatever works, and I get it.
Yeah.
I remember for my first principal architect job, I had like 3 or 4 interviews with SMEs, and then they flew me to San Jose and scheduled an 8-hour day of training. And I met with this guy Kumar, who actually wrote the BGP code at Riverstone.
Yeah.
He now is the CEO, or he was now the creator of Versa Networks. And it started out with, I'm going to check your competency in BGP. And I'm like, okay. And 45 minutes later, 55 minutes later, 59 minutes later, I'm thinking like, I don't know why I keep knowing how to answer this. I must be having a really good day. Maybe I ate my Wheaties. Maybe something gave me creativity. And then all of a sudden he asked me something that was so ridiculous about some bit that was set in some flag somewhere. And I said, Kumar, I just don't know. And he's like, good. He said, I wanted to see where your breaking point was. And I wanted to see if you're going to lie to me like everybody else or just be honest where you didn't know. And that stopped the interview. It's like, nobody gets this far. But yeah, I get it. And let's talk about the difference now and where these architecture careers actually went. And Russ and I, in many ways, took our career in the same direction. And in many ways, we actually took them in the opposite direction. And I'll explain. So Russ is that distinguished architect, which is by every definition an industry known leader. There's no one Russ is going to go, no major networking conference where they don't know who he is. He's widely known by the C-suite. He's known as a technical expert. Anywhere you want to go, they know him on his technical basis. I took the exact opposite route. I started out very technical, and I went into the executive, more businessy architected roles, the enterprise architect role. And my job went from being a subject matter expert, as it turned out, on IP multicast and IP multicast video and all the things you could do with IP multicast. And the next thing I realized, now I'm wearing a suit each day, and I'm now in a boardroom every day, and I'm now in an executive briefing every day, and now I'm in business councils every single day. And now I spend more time schmoozing, buying lunches, buying dinners, and buying drinks, and meeting with the C-suite people talking about business optimization and process engineering. Either one is an appropriate way to take your career.
Yeah.
And at the end of the day, if you look at what Russ will do or what I'll do, they're still going to be the same thing. I may spend a little more time at the C-suite information gathering, and then what I'm going to do every single time is I'm going to go build my team. And even though I know network architecture, if I'm that chief architect, I can no longer be the network architect. So it's like, okay, there's this guy, Russ White. He knows this. He's an expert on this. Let me find him. Now, there's some IP video thing, and I no longer am the guy, so let me get the IP video. Now there's unified communications. Let me bring them in. And even when I was at Cisco, I always had a team of 15 to 50 people to come up with anything big. Because anything big is not done by one person. And
and by the way, it's the same. People think that I would, for instance, jump into a technical problem and just do it all myself. And that's absolutely not true ever. In fact, I am very intentional about, no, I don't do this. Even when I am the quote unquote subject matter expert on a BGP problem, which almost any room I walk into, when we're talking about BGP, I'm going to know pretty much everything that they're going to be talking about. And that's fine. But I am not going to go in and say, no, this is how we're going to solve it. That's not the way things work. I'm going to find the people at the company where I'm working, wherever that is, and we're going to sit down and have a discussion, and we're going to get them to pull in and pull their ideas in and make sure that we understand, because even though I may know a lot about BGP, I may not know a lot about your particular circuit setup. I may not know a lot about this, even for a company I work for, frankly. I've been working at Akamai for 3 years. Don't ask me all the places that Akamai touches the world. Don't ask me for every provider what communities we use upstream in BGP, or whether we peer loopbacks, or whether we use TCP/AO or MD5. I don't know all those details for every provider all the time. There are people who do. It's important for them to stand up, make their voices heard, and to let me sit in the background as much as possible and say, okay, but have you thought about? Because I know the protocols, and I kind of know enough about the business to be able to say, but wait, have you thought about? Have you done this? What have you done there? What are the trade-offs in this situation? There's got to be a trade-off. So I'm going to press into trade-offs all the time. So those, I mean, and I don't want to be corrective. I don't want to walk on people's toes. I just want to say, you know, I know this stuff. Great. Let's work together. I'm not here to shut you down. I'm here to like figure out how we can work together. And I think that's key to the architect role, no matter which way you go, whether you go more on the business side or more on the technical side, you know, don't ever be the guy who walks in the room and says, I know more than you do, so shut up and sit down and listen, because that's not the way things work.
You know, that is so powerful what you're saying. And I would actually say that most of our job is information gathering.
Yeah. Yeah.
I'd say what most people outside of architecture tend to do is they think of the problem that's directly in front of them and what do we do about it? Architecture is, okay, if I do this, what are the implications of this, and this? Okay, and if I use this, what are the implications of this, and this? Now, if I do this, what are the implications? And now it's like, okay, let's perform an impact analysis. Let's figure out what it's going to, each one's going to do, the strengths, weaknesses, opportunities, and threats of each approach, your typical strategy consulting. And then you evaluate all trade-offs, and then you select what's best for them at the time.
Yeah.
And you explain your rationale as to why.
And the future. Let's not forget the future, because I think from my position, 90% of the time, the thing that finds me most frustrated all the time is that people will say, I'm going to solve this problem this way. Fine. But now you either building a platform on which you can build new features and new products and new ideas and new ways of doing business, or you are building a platform to support the stuff that you have right now or in the past you had. There's no third way. There's no in between. It's either you're building for the future or you're building for the present and the past. There's a cutoff. And if you're building for the present and the past, my job as an architect is to say, stop, think about what you're doing. What do you anticipate producing in the next 5 years that might be impacted by this? And most people that are at the engineering level get very, very frustrated at that pushback. They do not like that pushback at all. They want to get the job done, go home for the night, watch TV, do whatever they're going to do. They're done. That's not the job of the architect. The job of the architect is, no, you've got to, what is, you know, even where I work right now, Akamai, 90% of my job is thinking about what new product could I come out with if I do this instead of this, where does that take me from a product perspective in 5 years? And salespeople don't want to hear it. Engineering doesn't want to hear it. You're in the middle of all these people who don't want to hear it. But that's your job as an architect. That's what you do. That's what it is.
Yeah. You know, it hit me. Cisco had asked me to teach they had come up with the architecture framework. I know you remember it, the service-oriented network architecture framework.
Yes.
And they tried to present it to the sales engineers throughout the company. And the sales engineers were, what the heck is this? This module, this module, this module, this module. And they're like, go form a curriculum, go show up on Sales Engineer TV, go show it. And people ask, what is it? And I said, let's be fair. Some people think they're just building networks. We're not building networks. We're building a foundation for the future that can enable that client to either communicate better, whether it be with data, whether it be with voice, whether it be video, to enable them to run new applications that can enhance their business, to find new ways to talk to their customers. And these are those types of things that we can ride on the network. So that's the whole point of what it's going to work. And they're like, oh, why did they say that? Like, because all architecture things are theoretical and they're not like practical hands-on things that people think about. Yeah.
They're abstract. And a lot of people struggle with abstraction. Honestly, it's not a skill we teach. I don't even know how you teach it. No. Honestly, I actually don't know how to teach abstraction. And yet abstraction is beyond the shadow of a doubt, the most important skill you can have as an architect or even as an engineer, being able to abstract things out, zoom in and zoom out, take the 5,000 foot view, take the 2-foot view, you know. It's like when you look at a map, you want to be able to you want to hit the scrolly thing and go down and see the individual house and scroll out and see the path to that city. That ability to abstract and move in and out like that is beyond doubt one of the most important skills you can have. And again, I don't even know how to teach it. It's just like something, I don't know how you pick it up or what you do, but
sometimes people often, I always initially I would think that engineering would prepare people for architecture careers, and under certain circumstances they do. But in so many cases, when I get an engineer that I train to be an architect, I have to untrain the way they were taught to think, which is often hard, and then go to a more strategic thing. I think what helped me with architecture was actually studying medicine before I went into tech. And as crazy as that sounds, I built a map for myself, and I said, okay, whatever happens systems theory-wise, one system affects another system. So I think about the brain and the spinal cord and the nerves. What does the neurological system do? What does the cardiovascular system do? What does the circulatory system do? What does the hepatic system? And I used to think of the systems when I learned medicine, what would it impact what, and along the way. So when I went into networking, to me, it was an odd thing. I did a CCNA, CCNP, and a CCIE in about 9 months and said, okay, now I'm certified. I'm ready for my first networking job. Now I got to learn networking after I got it, because we all learn differently. But the thing for me was, it's the implications of one to the other. So when I teach architects, I bring in a lot of those strategy consulting things that we would do as strategy consultants, and I try to teach some McKinsey things, and I try to bring it in because there's no way to teach it. And I often say engineers help and hurt. And here's what I mean. If I've got an engineer like Russ is talking about, and if we're talking about an engineer, let's say it's a cloud engineer, and if I approach that cloud engineer and ask that cloud engineer and I say, we've got an application that's got sluggish performance, what could be the things along the way that could cause the problem? If that cloud engineer could say, well, it could be the CPU, it could be the disk IO, maybe we need DRAM and we're hitting the page file, maybe we've got a constraint on the network, maybe we've got a code that's written, anything. But if they can give me the holistic spectrum of what's wrong, that type of engineer will be very good in an architecture role.
Yep.
By comparison, the ones that get 5 or 10 different associate certifications that know the name of something and how to configure it, but when you ask them about the technology, what it is and how it works and how they can use it, they have no idea. That's actually teaching the person the wrong way of thinking. That's more of a technician, where this is more, which is fine. And we need people like that. But for architecture, it's about strategy. It's about planning.
Yeah, right. When people go into the CCIE, and this is actually my complaint about these certifications a lot of times, is that the goal of the CCIE is to get on the keyboard and go fast. That's a lot of what you get when you get into with people when they are learning their CCIE. And there's nothing wrong with getting on the keyboard and going fast, but it's not going to lead you to architecture.
No.
It's just not going to. You have to move beyond it. And it's a good place to start sometimes, but you have to move beyond it. You have to get to the point where you actually understand, all right, if I look at this network, and this is a prime skill that's really hard to learn for a lot of people, I'm going to look at this network, and you're going to tell me it's running IS to IS. You fail this link, I should be able to tell you what's going to happen, which router or which router intermediate system is going to advertise what first, how that network is actually going to converge, step 1, step 2, time 1, time 2, time 3, time 4. What is that network going to do? And if I want to change the way that network converges, then what do I do to the design, to the physical infrastructure or the logical layout of things, aggregation, whatever it is, to make that change? That's when you're at the point where you can actually do network design, and you can walk into a big network failure and look at the diagram on the board and go, yeah, your problem's here. I can tell you where your problem is, because I can tell you the way it's converging is that looks like that's where the issue is going to be. You've got to be at that point. And if you're going to do that kind of stuff, so do the fast stuff on the keyboard, fine. But don't get trapped in it for the rest of your life. Don't stay there. Move on. Learn how the stuff works. Because as you said, that's really crucially important, is learning how it all works.
Yeah. And when I tell people the CCIE was just an intro to networking, and a lot of people think I'm crazy, but to me, that was just an intro. It's like, okay, now I understand.
It's baseline.
Yeah.
Table stakes.
It was just, Yeah, it was
Yeah.
table stakes. That's like, okay, to me, the CCI was like, okay, now, Mike, you're invited to the party. Now we're going to give you the really scary stuff that you have absolutely no idea how to deal with, and you're going to go figure it out. That was what I got out of the CCI. Now it was like, okay, great. Now all of a sudden I'm a senior architect on Wall Street. Now I got these extreme boxes. I've got these WAN compression boxes from Expand that are doing this. There's these load balancer things that are going this. Wait, why do we run this? Why are we dealing with all this spanning tree nonsense when we can do layer 3 links? And it was like, it was all kinds of icky.
Yeah.
And it was like, okay, let's just fix this. Let's just fix this. But it was all like, wow.
Yeah.
And that's why I say, these certifications really don't prepare people for these kinds of roles.
Yeah. Well, no, they don't. And they're not really designed to. I mean, they're just not. I mean, the Cisco certified architect was, but it's kind of gone.
Yes.
But, that was part of the idea was, I mean, honestly, where did the CCIE come from? The CCIE came from Cisco TAC. And the idea was, if I have you on the phone, if you call me and you have a problem, then if you are a CCIE, then I have a sense that as a TAC engineer, that you have checked the baseline. You know what you're doing well enough for me to work with you. It gets you into the more senior TAC rep immediately. It became a lot more than that, but that's actually where it started. And on the TAC side, it became an expectation. If I was taking cases, I was a CCIE. In fact, the whole CCDE CCIR program came out of a bunch of us walking into customer sites and not having and being unenthusiastic about the CCIE because it's just not what we did anymore. And it's like, it wasn't, we're not saying it's a bad certification. We're just saying this is just not what we do. And so, the marketing people were like, and the sales people were like, wait, you can't go to a customer and say that you don't really care about your CCIE or whatever it is, because that looks bad for the program. So what can we do to certify you a different way? And so, I mean, that's really a lot of these things, where these things came from was, again, the CCIE is not bad. There's nothing wrong with it. Absolutely. No. If you want to get it, go get it, please. It's an awesome certification, but just don't expect it to make you into an architect. That's all. Take it for what it's worth.
And I feel fairly strongly about that. One of the executives at Cisco asked me to remove the CCIE from my business card while I was at Cisco. And he said, it's creating the impression that you're a techie. I need the world to see you as an executive. And I went, okay, that kind of hit hard. But I love the CCIE. It was a great engineering exam, but that was the key. It was engineering. And it's that engineering versus architecture. And if I actually look at it, the only thing that closely resembles an architecture exam is actually the CCDE. And I'm not going to say that's exactly what we do, but at least it's somewhat like it. Yeah. AWS has courses on solution architects. And literally speaking, it's about the name of a service and how to configure it. And they literally don't even teach you how the technology works. In fact, they made up marketing terms so you don't even know what it is. Yeah. I look at this and I literally, the reason I created this training program is I bought a kid that was a friend some training courses for, and they were solution architect courses. And then after 3 days, he said, Mike, I set up objects. He set up an S3 bucket and an EC2 instance. He said, wait, is that, Mike? I'm like, what do you mean? Let's talk about a virtual machine. Talk to me about the server. Talk to me about the processor. Yeah. Talk to me about the DRAM. Talk to me about the processor architecture. Talk to me about the hypervisor. And he said, what's that? And I said, what do you mean, what's that? You just passed this. And I went, oh my God. And I started looking at it. And that's why I started teaching architecture. Where, how did I teach the cloud? Well, I had to start breaking it down to the network and the data center, because that is the cloud. Yeah. And then talking about what are these, how do they work, how do you use them, and then what are the virtualized versions of them? And that's the key. I mean, people don't realize that, and I've literally seen people, because they don't understand the history. I've got this new exciting thing for you, a virtual link that's going to connect you privately over a backpack. I mean, you mean like a tunnel? You mean like whether it's a Martini tunnel or this kind of, they're like, yeah. So it's not new? No, it's 20 plus years old. We've been doing this stuff forever.
Yeah, it's crazy. Yeah. Yeah. And the CCDE did start out there, by the way. It did start out as it started out as we need to be able to figure out how to teach people, or to certify people on design. And that was, I think, as I recall, it took us 4 or 5 years, maybe 7 years to do that certificate, to build that certification. And it was very hard. And it was a lot of like 3 days a month sitting with psychometricians and saying, all right, this is what we're trying to measure. And they're saying, really? You're trying to measure that? Like that's you, how, what? And so that was a lot. That was a lot of the CCDE was figuring out like, how do you measure this? And, originally it was supposed to be a board certification, but board certifications are very hard to maintain. They just are. They're just hard to, you just can't get enough people and you can't make it consistent enough to make it psychometrically sound. That's the problem.
Yeah.
And as a company, if somebody comes in and says, I was meant to get a raise and I didn't pass this because the board didn't like me, they didn't like the color of my shirt, or they didn't, you can't put yourself in that legal position as a company. And so it just becomes a big problem. So.
Yeah. And Russ is hitting on something that's really important. I'm going to give a list and I'll have Russ react to it. As architects, we need to have expert communication skills, both to be able to get the requirements and also be able to communicate them and sell them. We also have to have good sales skills, because it doesn't matter how good anything what we do is if we can't convince people to use it. We have to understand business and inputs of business and business processes, because if not, we're not going to be able to design something to optimize the business. We have to be able to lead a team, because for the most part, no architecture is by a single person. Now, at the same time, we need to be able to communicate to the C-suite in things they care about. For example, I'm not going to talk about RSVP tunnel signaling to the CEO of a business. It's just not going to work. They'll escort me out of the room with security. And those types of businessy skills, to me, are everything. And at least they're like 60, 70% of the job. But how do you test for that? How do you say Russ's skills are a 9 out of 10 on communication, or this is a 6 out of 10? What are you looking for? How do you measure it? What's the criteria? It's a lot harder than to say, I broke Mike's CCIE exam, and on day 2, he had to rewire and go figure out what the problems are, and it'll put it back together. That's easier to quantify. Is that what you're referring to?
Yeah, that, and just even the ability to say, this is the system, let's look at the trade-offs. So sales is specifically where I really stink. I'm really bad at sales skills. It's just not part of my lexicon. Communication skills I tend to do pretty good at. The ability to like see a system and understand the whole system in a single block. That's a very mental mapping. I'm very good at mental mapping, taking a situation and figuring out a mental map of where everything is. I mean, even politically, like I can go into an organization and it's very easy for me to mentally map, this person's the person that I need to talk to about this. And I need to go, that person's going to be somebody who's not going to agree with me. And I'm going to have to go figure that out. That's the mental mapping bit. And so I think mental mapping is, again, a skill that's grounded in abstraction. As far as measuring those things, I actually don't know. A lot of times we tried to come up with different strategies for the CCDE. It almost feels like you have to do a board exam. It almost has to be one-on-one to do some of these things, to understand where somebody is. Yeah, that's always.
It's not an easy thing to actually create one of these certifications and run them, because at the end of the day, the board or the panel has to be an expert in their job too. And the experts in their job, they're all usually pretty busy running and from place to place, meeting people for people. It's not like there's 4-hour days for the people that are actually known and respected throughout the world.
Yeah. And they have to be good at psychometrics. They actually have to know how to fill out a rubric correctly and know exactly how things apply the way they need to be applied. And that's an entire skill set that's very rarely exercised or understood. The only place we really run into it is in interviews. And frankly, we all suck at interviews. I'll just be honest. Most people suck at interviews. Interviews are like, that's a skill set that almost no one has. It's really, really sad how bad we are at interviewing.
It's funny. I have been training someone from interviews, and someone in the Middle East just sent me a message today. I got hired. Thanks for your interview training. If you approach the interview, it's all about sales. It's about learning how to position yourself to show that you are a solution to somebody else's problems, to show you that you're those things they're looking for, which is someone that's competent and capable, that's willing to work, that's willing to go above and beyond, that's a great team player, that is energetic, enthusiastic, and passionate about the job. And it takes a whole lot of psychology, a little bit of neuro-linguistic programming, a whole lot of learning how to answer questions, line of fire kind of training like you're talking about, a whole way to actually figure out what the person's actually asking you. So you know actually how to position it, all at the same time where you're reading the person's body language and you know whether to continue or shut up or stop. I actually have an interview training program because that was something that I focused on for me. And the reason I focused on it was when I started my tech career, the only degrees and skills I had were in internal medicine. And I was trying to get my first job and I'm like, I got to figure out how to plan this. So that I literally went through like 15 books on sales and psychology. And I had studied a lot of psychology in school. And I was like, this is interesting to me. And I tuned it. And I've been working on coaching interviews now for over 20 years. But yeah, that's a skill. And you know, what Russ is highlighting is one of those skills that's really critical. And why is that so critical? Because you've got one of these jobs. Let's say you're dealing with a principal cloud architect job. If we pick Google, for example, we're dealing with a pay range of $394 to $677. Wait, what? That's like $275,000 of a difference between the top and bottom, maybe a little more than that, almost $300,000. And it's understanding how to make yourself very attractive to the manager, showing that manager you are what they need, because most people don't focus on it. And if you've got someone that doesn't focus on it, then it's based on either chance, it's based on luck, or you're just so good like Russ that anybody's lucky to have you. But I don't like to leave a lot of things per chance like that.
Yeah.
I'd probably try to prepare and sell these things. So I agree.
Yeah.
You know, it's interesting. Go ahead.
Go ahead. No, go ahead.
What I was talking about is, you see how the way Russ says, I don't like to sell, it's not me. And that's great. That's fine. That's why he went down this distinguished architect path. And I went to where he gets to be compensated for his expertise, because the distinguished architect is that industry expert. I always found, here's how I learned that I needed to learn how to sell. And this is going to sound crazy. I'd say about 3 years before I went into networking, 5 years before I went into networking, I tried to prescribe a patient Coumadin. They had a heart condition called AFib, and with AFib, there was a 30 or 40% chance that they would have a life-changing stroke at the end of the year if I didn't do anything about it. And the treatment in those days was Coumadin. Now, Coumadin is it prevents the blood from clotting. Now, Coumadin is also used as rat poison because the rats eat it and then they bleed to death. So I tried to save somebody's life, but prescribing some Coumadin for them. And the patient said, no. And I was still in school at the time. So I went to the physician that was my preceptor and I said, how do I convince the patient to take this? And he hands me a Dale Carnegie book and he said, Mike, you need to learn to sell. And I said, huh? I studied medicine. And he said, Mike, how are you going to convince your patient to lose 40 pounds, to stop smoking, to exercise, to take this medication that has side effects, unless you learn to sell? And I went, okay. So for me, I took sales class after sales class after sales class. I'm like, I like this thing. But you see, that's why you need different kinds of architects, and we have an architect team.
Yeah.
Because if I've got someone that can look at every thing and from the networking side, and then I got another application architect that's good at the application side, and then I've got an AI architect that's doing their AI thing, and I've got another architect that can sell and convince the board to go spend $1 billion on a project. That's my dream team. I don't want to turn Russ into a salesperson if that's not what he likes doing. I want to celebrate Russ for all the great expertise that he has. At the same time, if you've got someone that's really good at sales, send them out on some of these sales calls, because they're going to impress the board and be more likely to buy. And that's where I think we've got a lot of wiggle room in how we take our architecture careers.
Yeah. And I think part of it is just knowing your own range. Like I have a pretty broad range. I mean, for somebody, for what I do, I mean, a PhD in philosophy, and I write and I do a lot of teaching, and I'm actually teaching a class in the spring at University of Colorado, and, you know, all this other stuff. But I just know that given the amount of time I have in a day, could I go develop sales skills? I probably could, but then what's the trade-off? What am I going to, what is the trade-off, right? Am I going to create less material? Am I going to write less? What am I going to lose by doing that versus what am I going to gain? What's my return on investment? And for me, it's just never been something that I believed would give me the trade-off that I was after. And so it's got to be passion plus trade-off. Those two things have to be combined. And so, I had more of a passion for the philosophy. So I could have gone and done this other stuff. But, I decided to do philosophy instead of doing sales or something like that because I had more of a passion for it. Now, honestly, the philosophy thing doesn't give me a lot of trade-off. I don't get a lot out of it, but except just me being who I am and enjoying, that type of stuff and knowing that stuff.
Yeah. And that's the key. Anything that gives us a different perspective of the world actually helps us in architecture because it gives you a different way of thinking. And to me, architecture is all about creative problem solving. There's so many ways you can do it, so many approaches to it, but the real key is, are you aligning the people, the processes, and technology at the end of the day?
Yeah. It's interesting. Johnny asked a question there. I don't know if you want to look at it.
Yeah, let's talk about it. So from Johnny VPC, if you guys want to pop it on, Tyrone. Hi, Mike and team. Right now, I doubled sales for selling CMS solutions for an agency that I really no longer want to work for. By CMS, I think you mean content management, or you could be dealing with a medical thing too. So because that acronym could serve two things. Could you let me know? How do you combine your sales skills and UX skills to sell cloud? So we can, and then there's a second half. You can also edit videos, build sales sequences, pipelines, and you love selling tech. Never thought a diagram and Cloudcraft and whatnot. Okay, so we can both give you two different perspectives. So for me, tech sales is about solving customer problems.
Yep.
Which means what you need to understand is learning the organization that you're dealing with, having the business acumen to look at a financial statement, a balance sheet, being able to understand what industry analysts are saying about that organization, being able to listen to the CFO and the CEO where they actually talk about their constraints, being able to evaluate the business processes that they actually have, evaluating the business challenges they actually have, and figuring out how whatever product or solution you actually have can make them better. Yeah. Now, that means you need to know two things. One is you need to have a good background of business and sales. And I'm not going to say you need an MBA, but you need that level of knowledge to be able to sell into tech, because we're dealing with billion-dollar sales, hundreds of millions of dollar sales. I know, Russ, you worked on billion-dollar architectures, I'm sure, because I know I have.
Yeah.
I'm sure many of yours were. So there's that. Now, the next thing is you need to understand what you sell. So I'm not talking about an engineering level of knowledge, but if I was going to be selling cloud computing, I would need to have some knowledge on those networking and data center technologies that I'm actually selling. And I would need to know very heavily how those technologies could be applied to various business problems.
Yeah.
Much like the executive architect that I'm talking about, but now more business acumen and more finesse and more experience entertaining clients and taking people golfing. And generally speaking, it involves a fairly good Rolodex, because you need to be able to speak to people fairly easily. Which CIO can you get on the phone? Which CTO can you get on the phone? And these are really great jobs. These sales jobs are high-paying jobs. They're good, but they're different than regular sales things. Because now Russ is going to design $1 billion architecture with a team of architects. Now, how do you sell $1 billion architecture? It's not like selling a car at this point. Whereas, imagine how good you're going to feel on these buttery seats and the 800 horsepower engine. Now it's building a business case and building an ROI model that shows, okay, you invested here. And this is when it's going to drive these business benefits for you, because you're also going to have to be able to understand that businesses have to evaluate their opportunity cost. Meaning, I got $1 billion I can spend here, and I got $1 billion I can spend here. Which is more likely to be able to generate a better return on investment for our spending, because we can only spend it once. The opportunity cost piece, you're going to have to do that. But if you can get these skills, and they're great skills, you will have a great sales job. And I love selling things too, but I kind of have an approach to sales, and I've sold a lot over the last 25 years. I'm not really a salesperson per se. I solve people's problems. And what I mean by that is, if all of a sudden you've got an inefficient sales process that's costing an organization $100 million a year, and I can come up with some technology strategy for $30 million and show them that they're only going to spend $30 million to get $100 million, that sells. It's proving to them that it works. But Russ, why don't I give you a perspective too?
Yeah, that's fine. So I would add 2 more things to what you've said.
Please.
Although we've talked a little bit about it before. Don't just learn the cloud technology to sell cloud, how to configure it. Learn how the stuff works. I always use rule11.tech. I'm a big Rule 11 fan. It's RFC 1925, Rule 11. And it's all about everything is the same over and over and over again with different names. So when I model networks, I use the RENA model, but I use an extended RENA model. I call it the 4 things model. There are 4 problems to be solved. Each of those 4 problems has about 3 to 5 solutions, or it has 3 to 5 subproblems. And if you know that chart, if you know how to ask the right questions to figure out how the technology works from the backside, how it actually works, not the packet formats, not the neighbor formation, all that other stuff is fine, but whatever, how it actually works. So I would say being able to talk to a customer or to a prospective customer that you're trying to sell to, and they say, I need to solve this. And they're using terms that are different than yours because they're not in your cloud ecosystem. You need to be able to relate that, understand how the problems work, and know what to tell them to use. All this proprietary talk from the cloud providers makes this very confusing intentionally on their part. So that's one thing I would say. The second thing is, don't leave it with just where they are today as a business. Think very hard about, all right, they sell tennis shoes. All right, you have a tennis shoe company and you're trying to sell them cloud services. Awesome. Okay, what's happening in the shoe market in the next 5 years? Is zero drop coming? Are new materials coming into footbeds? Are people looking at new styles? Can you talk to the business not only about what they do today, but like how your technology impacts or how their technology decisions impact future market changes that they're not thinking about? An example, I used to work for BASF, and one of the vice presidents, Dr. Schmidt, walked up to me one day and he said, you have all these technology ideas. Now, this is like I don't know what it was like 1993 or not 1993, 1994, something like that. And he said, you have all these technology ideas. We are a chemical company. We sell chemicals. If it doesn't help sell chemicals, we don't care. And I looked at him and I said, Dr. Schmidt, that's great. But let me ask, how do we know who to call to sell chemicals? How do we know how to project how many chemicals to sell, how many to produce, what we should be building in factory space for future chemical cells? He says, well, that's all data. I'm like, no, BASF is not a chemical company. BASF is a technology company, a data company that happens to use the data that they have to sell chemicals. Let's straighten ourselves out here. We need to back up and look at what we're doing and figure that out. So those are the 2 things I would add is like, okay, if you're thinking about going into sales, those are things you need to have skill sets in to be able to talk to that company and have them trust you as a partner to make technology decisions with them.
That's it. And I'm going to touch RFC 1925. I had a company many years ago, and I had a very similar situation. Why do I need to upgrade the network? And it was one of these systems where people didn't get it. And I said, well, right now you're a manufacturer, right? And they said, yes. I said, do you have partners that you get parts from? And they said, of course. I said, how do you deal with your supply chain? Are you financing things to keep things in stock? Are you getting things when you need it? Oh, that's a big mess, Mike. I'm like, okay, so what if we could optimize your supply chain? Now, what if along the way, we can make sure messages were sent to the right people along the way so things didn't get lost? Oh, that would help us too. Now, what if we could better predict demand and we could make sure you have the right things? And they said, that's great. And I said, then what if we can learn better from it? And they're okay, I need it. And that was the key. See, Russ and I are going back to the same point. We're not engineers. But I really want to talk about what Russ said, which is very important. The reason I say you get very little benefits out of like an AWS solutions architect professional or an Azure solutions architect expert or a Google professional cloud architect. Yes, it will get you an interview, but it won't help you 1% on your interview is as following. because I don't care if you know that a virtual machine is called an EC2 instance. I can't communicate that with my client anyway. I still have to call it a virtual machine, regardless of whether it's in the cloud or the data center.
Yeah.
My CIO understands block storage, object storage, and file storage, but they don't know S3 or EBS, and I can't even use it. More importantly, the world is multi-cloud. So I can't use any of this cloud proprietary stuff. I need to use things that are open standards anyway. So at least 50% of the stuff on a certification, throw out. But like Russ said, you need to know what's underlying and how it works. You can't design that. But Russ also mentioned my favorite, absolute favorite RFC out of all of them. And the reason it is when people say, Mike, how do you stay up to date? And I say, if your fundamentals are good,
yep,
you'll understand everything, and you'll see that each new thing is a version. So let me give you the
get off the treadmill. Off the treadmill.
Yeah.
Get off the technology treadmill if you want to keep up. Get off.
Exactly.
Yeah. So
listen, these 12 fundamental networking truths. It has to work. So I can guarantee me and Russ spent a lot of sleepless nights figuring out how to make systems work when they need to.
Yep.
And here's another one. No matter how hard you push, no matter what the priority, you can't increase the speed of light. So what do we mean by this? Ultimately, over a wide area network, even if it's fiber optic, you can't get faster than the speed of light, which means there's going to be latency. So far, we're so good. Now, this one's kind of funny. With sufficient thrust, pigs fly just fine. However, this is not necessarily a good idea. It is hard to be sure where they are going to land, and it could be dangerous sitting under them as they fly overhead. Now, what are they really talking about here? Just because you can do it doesn't mean you should do it. And I can tell you, Russ and I have seen some science projects over the years, and we can't even imagine why somebody did it because we can't figure out the outcomes. Now, the next couple are kind of interesting. The next one is some things in life can never be fully appreciated nor understood unless experienced firsthand. Have to agree with this. Some things in networking can never be fully understood by someone who neither builds commercial network event nor runs an operational network. When you try to explain the complexity in a network to someone and they have honestly no idea what goes on, it's just going to seem like wizardry and they can't imagine it's that complicated. It is always possible to
agglutinate.
Agglutinate. Wow, yeah. Multiple separate problems into a single So basically combine multiple problems in a single problem.
Yeah.
Absolutely.
Yep.
And
Never
a different part of the network architecture. Yeah. So I'm glad, yeah. So it's easier to move a problem around, for example, by moving the problem to a different part of the overall architecture than it is to solve it. Oh, wow. How many times have we just done something ridiculous because it was the only thing we could do in the medium time to get things up and operational until we could figure out a long-term strategy, which was going to take a long-term mitigation plan.
Yep. Yeah. Yeah. This is an awesome RFC. If you've never read it, you ought to go read it. Hey, there were a couple of questions in the chat. I don't know if we want to handle Mark Millivan. There we go. Yeah. And so this was about diversity. All right. So this is a personality quirk of mine. I've always been this way. And I don't know how to tell you to develop it or if you even want to develop it. It's just a thing with me that I grew up doing engineering. I got my amateur radio license when I was 12 years old. Seriously, everybody in my family is an engineer. Even my mom, when she was actively working before she retired, she wrote bash scripts and console scripts and coding. She coded for accounting systems. She was a CPA. I mean, she was an accountant full on. But when she got into accounting, she realized she couldn't do a lot of things without automating it. And so she learned scripting. And so there it was, she had to do it. So she learned Linux and stuff. And she's an amateur radio operator, and my grandfather's an amateur radio operator, and all my aunts and everybody in my family's engineering. So I grew up with this totally curious about everything. I don't care about how you make it, tune the knob. I want to know how it works. It's just built in to my entire life, this curiosity level. And then my grandfather was, he sold Ford tractors for many years, but he also was a county agent. So he went around and blasted ponds and fished. And so he had the same curiosity level about growing corn, like, crazy stuff. And then for whatever reason, when I was in school, I got into art. So I did illustration for a living and music. I played piano for 12 years before I finally gave up lessons. And so it's just always been a thing with me. I am very diverse, and I always believe that all these things come back and build a body of knowledge, a mental map that helps me understand things a lot better than if I didn't have that diversity. And so it's partially just curiosity. It's partially I just enjoy learning new stuff. And it's partially that I really think that it's important to have that kind of diversity, to be a whole person, right? This is where I get off on college degrees. Why would you go get a college degree? Well, I have my certifications. I have a great career. I see this all the time on X and all over the place. LinkedIn is I don't care about degrees. I care about degrees because I'm a person. I'm more than a machine that sits here, types on a keyboard, and builds architectures. I'm a complete person. I need to be a complete person. That's just the way I am. And so that's kind of my diversity answer. I don't know. Anything you want to add to that?
I think that's important. The key is every lesson we have helps us.
Yeah.
I learned internal medicine. That helps me so much think in terms of what if, then this, and the knowledge that I need to have extremely deep knowledge to be able to get things done. Great. But you know what? Somebody else has a different solution to another problem. Someone else has a different solution to the problem. And the key is I want that whole person. And I don't want a team of all the same people. That's the worst thing I can have, because if they're all the same people, they all solve the same problem in the same way. I need creativity. And if I've got a philosophy person, great. If I've got a person that studied history throughout, they probably have an idea of cause and effect because they've seen if what happens was. If I've got someone with great degree of macroeconomics, well, that person's going to help me predict the future to a degree, which is going to help me design my architecture. So all this is good, and I love that. So Mark's on our team, actually. I just wanted to highlight that.
Yeah, and I think it's true. I think that creativity, we tend to think of creativity as being a deeper dive into what you already know. No. Creativity happens at the edges of all the things you already know. That's where it happens. If you take a mental map or map your knowledge space, your creativity is going to happen along the seams between things that people consider separate. That's where the creativity happens. And so that's always been true. And I think that's a very important thing. If you want to be a creative person, be a broad person. Build range.
Yeah.
Build your range.
You know, it's funny. I was telling my students the other day, I remember I had a friend that was doing some advanced degree in math. And while they were doing their advanced degree in math, they had to calculate some kind of area under the curve, but it wasn't like a normal calculus thing. It was enormously complicated. And they looked at me. They're like, Mike, can you do this? And I'm like, sure. So I said, do you have a second copy of this paper with the area under the curve? And they said, yes. And I used an X-Acto knife and cut along the curve. And I weighed the paper, one side of the paper, another side. I said, calculated the percentage and said, there you go. And the person said, I don't know if this is what I was supposed to use. I said, doesn't it get you to the exact same result?
Yeah.
And they looked at it and they're like, well, that is one way to solve it, because that's the only thing that I could think of. But yeah, I'm not a math person. That was a math person. He had tunnel vision in math. And I'm like, well, here's what I would do. You know, something else.
Yeah.
So I love that. And that's the point. And it's a great question that Mark, you brought up. Having people that are whole people that actually have other things about them that can strike up a conversation with a client, that can actually build a relationship, that are interesting. I love that.
Yeah. So then there was another question in there about methods of let's go down to Jose's, because I think we've hit that one. What methods have you mastered to understand and remember IT? And I'm just going to go back to the same thing. Get off the treadmill. I don't care how it's configured. I care about how it works. If I know how it works, I can figure out how to configure it. I don't want to know how to configure stuff. Thanks. But, it's not that I can't do it if I don't have to. I'm not going to be as slow as the guy who's been doing it for 20 years and is currently doing it, but I'll figure it out. You give me the problem and I'll figure it out. And that I think is the key. And
that is the key. And Jose, we've actually spoken a little bit. So if you understood BGP at the level that I was describing the other day, where you understood every message and everything that needs to occur and why things would be updated or not, and you understand the protocol enough to say, why might you want to use something like dampening?
Mhm.
What is the reason you would want to use dampening? What happens if we did a traditional just reset of the neighbor? And you're able to think about all those peering sessions, and you're going to be able to think about all those things that need to come in, and you're going to be able to think about all the calculations that need to occur and what that might do and how long that may take. Then you're understanding the architecture. If you're learning router BGP 65312, neighbor 192.168, remote AS 65314, that's not going to get you there. It's understanding, the protocol. Same thing for OSPF. And cloud is just data center. And you can't learn the cloud by getting certified by a cloud provider. You have to learn the data center. Because when they tell you they got this magic thing called the transit gateway, it's just a router that runs BGP. When they tell you have an intergate gateway and they make up 18 million funny, ridiculous terms for it, the reality is it's just a router that connects to the internet. When they tell you about a load balancer, it's just a logical version of the same load balancers Russ and I have known about for the last 20 some years.
Yeah,
when they talk about IAM, it's just some flavor of the same Active Directory or TACAX or Radius that Russ and I have used for the last 20 years. None of it's new. When they talk about an SQL database, fine, IBM invented one in the 70s. When they talk about object storage, 30, 40-year-old tech, it's not new.
Yeah,
they intentionally made up some marketing names to make it sound cool and exciting, but it's the same old stuff.
Yeah, because new sells, and it sells psychologically, not just on the realm of being new, but because it sells on fear of missing out. It really does. Yes. Oh, there's a new technology. If I don't go learn that, I'm going to miss out. No, if you understand the underlying technologies, you never miss out because you're always right there knowing exactly what's going on. And beyond that, beyond going beyond is to say, not only when would you use dampening, but when you shouldn't.
Yes.
Right? Because everybody's like, oh, cool new feature. Get my fingers on the keyboard. Go configure it. Stop. Cool your enthusiasm, because that's really not the best place to be. Trust me.
No. Yeah. So, Jose, if you can think about, instead of just being given a task and doing it, if you can think about how every component of it actually works together. So, for example, and I know we've discussed our training. In our training, not only do we go over every element in the network in a data center, and not only we get involved in the networking, but we talk BGP, but not only do we explain it for hours, then we're showing various use cases of it. Okay, we want to carry VLANs here. We want to go in between domains here. We're now dealing with virtual routing. It's here. Why are we doing this? What's the point? And when you get that, it's all easy. Yeah. And it's all be the same for you. And it actually was the last component. It was one of those things on RFC 1925 as well that says what's old is new again. It's all going to be the same technology. Russ and I worked with the Frame Relay Cloud. We both worked with the ISDN cloud, which we both understood. And that was a nightmare. And I know you and I were debugging Q921 messages from the switch thing and the Q931 call setup messages. And then it didn't work so much that they used to call it I still don't know.
Yes.
And all that stuff. So, but we learned it. And how do we learn it? We're like, okay, this is what this ISDN ridiculous thing is. These are the messages we're supposed to see from the switch. These are the messages that are supposed to set up a call. Now, great. So we figured that out. And out of nowhere, a couple of years later, we've got H3.323, which we're using for voice call setup. Not that much different. And then poof, we've got SIP. Not that much different because the elements were still the same. It was just the way it was implemented was different. So if you learned that ISDN, it's fine. If you learn frame relay and ATM and then that RFC 2547 BGP cloud, and then you worked on the VPLS cloud, guess what you really learned? An internet service provider that had a very large, very powerful internal network. They had an IGP, maybe they had MPLS, and they had a couple of switching protocols, but it was the same thing. Are we creating a virtual circuit in frame relay? Are we creating a virtual circuit in ATM? Am I creating a pseudo wire over an MPLS network? It's all the same. Nothing's new. It's just names have changed.
Yeah. Another perfect example is frame relay. And then you went to ATM and we had something called the broadcast and unknown bus or the bum stuff that we did, right? And by the way, that actually has analogs all the way back to SNA and all this other stuff. Anyway, starting at least at ATM, then Dino Ferronici did Lisp. And by the way, it uses a broadcast and unknown. It's exactly like it works identical to ATM bum. And then you go to EVPN, and EVPN has broadcast and unknown, and it works identical. It's different packet formats, fine, whatever. But the principles and the order of operation are almost precisely the same, going from ATM through Lisp to EVPN. It's all the same stinking thing. If you knew ATM's version and you knew how it worked rather than how to configure it, you would already know Lisp version and you would already know EVPN's version. That's how you keep up with the technology right there.
Yeah.
Because I don't care what name you put on it, it still works the same way every time.
Yep.
So, yeah.
And we can go with example after example. I know Russ remembers the old CLNP.
Yep.
And the old CLNS routing.
Yeah.
Now all of a sudden we have intermediate systems to intermediate systems and service providers. Same kind of concept.
Yeah.
What did we have to do 20 million years ago, Russ and I, when we had Apple Talk and IPX networks over an IP network? We created a tunnel.
Yeah, we created tunnels.
Like a GRE tunnel. Now, what do we do in the cloud? We want to push multicast through it. We create a GRE tunnel.
Yeah.
It's not different. It's all the same stuff. Now, I understand if you look at the cloud providers like last year, I mean, you should have seen this big major announcement from AWS and all their solutions architects were on LinkedIn. Big news. This is going to change everything. Direct connections now support IPsec. And I was like, okay, the same IPsec that Russ and I were running over a private line back in 1998. Wow, congratulations. In 2023, we can do it on the cloud. It's the same stuff.
Yeah.
It's just now it's virtual, so we're playing catch up.
And even if they were doing, I would rather have them said, we're going to run TLS and quick instead of IPsec, because IPsec is a mess itself, right? And so, but it's the same thing. It's always the same thing. How do you exchange keys? Well, there's only about 4 ways of doing that in the entire world. How do I discover the topology? There's only about 3 or 4 ways of doing that. How do I route packets? There's only 3 or 4 ways of doing that. There's really not, this is not that big of a field when you really get down to it and learn it. It looks so big. It looks so huge. Honestly, it's really not. There's 4 or 5 problems to solve. There's 4 or 5 sub problems of each of those problems. There's 4 or 5 solutions for every problem. That's what there is. I mean, that's it. That's all there is. You're done. And the rest is all just naming and packet formats and configuration. And there's a slight advantage. I mean, okay, ISIS converges faster than OSPF in some situations, and OSPF converges faster than ISIS in others. And OSPF has this thing that it does, and it does better with metrics over here, and ISIS metrics are confusing over there. And nobody likes net numbers. They like V4 addresses for router IDs, like whatever. You know, it's still Dijkstra. Get over it. Like, that's just what it is. You know, it's just not. And by the way, those things do make a difference in your design. Let's be honest.
Yes.
They can make a difference in your design. If I'm in an OSPF network and I'm very concerned about convergence speed, I may opt for doing a lot of externals. You know, and I may opt for smaller flooding domains than I would in ISIS network of the same or similar size. That's fine. But those are just understanding how the protocol converges and stuff. That's not like, you know, once you understand shortest path first and Dijkstra, and you can do it in your head on a network in real time. Now, all of a sudden, you can start asking these other questions and understanding the answers, getting into detailed design decisions that make you much better designer.
Yeah. And if you really get it, you know, you're saying networking, cloud, and security. So cloud is really a data center.
Yeah.
Networking is obvious what it is. But if we think security, let's think about what we can really do.
Yeah.
Most of it, at least half of it's going to be on the network, whether it be an access list, a firewall, an intrusion detection, intrusion prevention systems, where we're a span port and sniffing, you know, whether we're using VLANs or whether we're using private VLANs or layer 2 access lists or layer 3 access lists or even QoS, that's all security.
Yeah.
Now we start thinking about what else. Well, on the routers, we still have authentication, authorization, accounting before you could log in and administer it. So now we've got the same IAM components that are in there.
Yeah.
Now we need a security policy, whether it's network or whatever. So now we've got a security policy. So yeah, Mel, maybe we add a data loss prevention system and a SIEM system, which is going to aggregate logs. But all in all, it's the same stuff that we've been dealing with for the same 25 or 30 years.
Yeah.
And that's the key to remember. We've got patterns. We've got various technologies. And to me, the technologies are like various kinds of drugs. And here's what I mean. If I had a patient that had a high blood pressure, I could use a diuretic like hydrochlorothiazide or furosemide. I could use a calcium channel blocker. I could use a beta blocker. I could use an angiotensin blocker or an angiotensin converting enzyme inhibitor. They'll all get me to the job. So now I figure for those high blood pressure, if those are the things that I need to choose from, which has the right side effects for my situation?
Yep.
Okay, now I can choose this firewall versus this firewall. They each do things slightly differently. They use a different anomaly kind of behavioral detection. This one uses this one uses this. So maybe we use both in different layers, or maybe we just use a single one because it's the best for our needs after we evaluated the trade-offs. Hope that answered it, Jose.
Yeah. So then Freedom had another question down there that I don't know. It's interesting if it's how did you get your first networking job? I don't know. I fell into networking. This is an interesting story for me.
I'm okay with it. I had my own wacky way to get into it. But
I was in the U.S. Air Force doing electronic engineering. And just again, because I was interested, I taught myself C and XBase in my own time. And someone in the group decided, oh, C. Oh my goodness, we could really use you in the small computer support center. So they took me out of my career field, which by the way, at the time didn't even have its own career field. Computers didn't even have their own career field in the Air Force. So they were like, we were just pulling people out of shops. And I was in meteorological navigational. So I was working on radar systems and radio systems and crypto and all sorts of other stuff. And got sucked into doing computers, which then ended up pushing me, believe it or not, into telco, because we deployed a large network on T3s on the Air Force Base. And they were like, well, while you're here, you could help us replace our old Stroger switch frame with a Nortel SL100, and that would be fun. And I'm like, I don't know about the fun part, but that's how I ended up pulling paper wrapped lead contained cables off of telephone poles and rewiring them with modern cables and pulling out Stroger switches. So if you ever hear me talk about clo fabrics and people go, well, that's kind of a weird thing. I'm like, well, but that's what we had. I mean, when I was in the Air Force and I was working on telco systems, we had clo fabrics built out of little 4-port crossbar switches that were mechanical relays. And then we had a 10,000 line Stroger frame that we messed with, And that was, so that's how I got into networking. Once I got there, then I started taking off on the whole computer side. And I was like, this is really cool. The electronic stuff is kind of going away. It's becoming boring. Honestly, that's what it was. It was getting boring. And the computer stuff was getting interesting. So I said, okay, well, let's go do computer stuff. And I started out doing coding, learning C and learning XBase and doing stuff like that, and coding a few things around the Air Force Base. And then I realized that I needed to get a Novell NetWare network up and running for the legal department. They asked me to walk over and do that. And that was on Token Bus, by the way. That's a really cool technology. It was on Token Bus. And so I got really interested in this. And so I went out and got my CNE, because why not? So I got my Novell CNE. And then I learned about Banyan Vines, and I went and got my CBE, my certified Banyan. And then when the opportunity came up to riff, I said, yeah, I'm going to riff. And I went and found a small company that worked on networks for a living, a little bitty consulting firm. And I went there and I worked on Novell networks and small Banyan Vine stuff for 2 or 3 years. And then ASME, the American Society, BASF needed a network person to manage their IT network. So I interviewed for that and I got that job. And then I went to ASME and a bunch of other places and eventually ended up at Cisco. So that's how I got into networking. It was through electronic engineering. and just like learning to code. Like I just picked up the C Primer Plus and just started banging away at it.
That explains a lot, Russ. I was looking at a document you put together, and I saw that the OODA loop was on there, and I'm thinking, I'm familiar with this. I actually teach the OODA loop to my students, believe it or not, and I'm saying, is Russ military? Because the first time I went on a military base many years ago,
forward deployed one time, and therefore the OODA loop was beat into our little precious heads.
That explains it. I was on an Air Force base 25 years ago, and I'm on this base, and they were having constant things, and I said, I think it's here, and I said, can we open and close links here? And it was like, so like, of course we can. And I'm like, okay, there's no change control. And anyway, so I said, here's what we're going to do. I think this is what I think. We're going to take ourselves. We're going to do this. We're going to observe what happens, and then we'll see what happens, and then we'll make a decision on how we act. And they said, you're talking about the OODA loop, observe, orient, decide, act. And I'm like, well, actually, this is the way I do things. So once I got past that and I started using that, it helped me so much. So when I saw it on your document, I'm like, was Russ military? Because I don't remember hearing that at Cisco. Because where else would he get the OODA loop from?
Yeah. Oh, yeah, definitely.
That
9 years U.S. Air Force. Yep.
Yeah, thank you for that. That explains a lot. I had a completely different path. I'd just been to school for. I had been an ER nurse. I had been a paramedic. I had been a firefighter. All of a sudden, I'm an internal medicine nurse practitioner, and I just thought the internet was cool because I could reach people in Greece and potentially not pay $4.25 a minute. So I just started experimenting with stuff because it was cool. Bought a couple of Cisco 2500 series routers, had a little lab at my house. And the next thing I realized, it's like, I'm going to work in tech. So I took a bunch of boot camps, which gave me a bunch of certifications, which nobody had any desire to hire me from them. I mean, they didn't care. I did a CCNA, a CCNP, a CCDP, an MCSD. And then I found a recruiter in San Jose and said, what I need to do to get hired. And the person says, you passed exams, you need to learn networking. And I said, what do you mean I need to learn networking? And he gave me a list of all the things. He's like, okay, how are you going to deal with a network that's got 1,000 routers? Where would your constraint points be? What are the differences between hub and spoke versus fully meshed versus partial? What are your reasons why and now? And he said, how are you going to constrain with WAN bandwidth when you're dealing with this and this? How are you going to do with the CPUs and the router? How are you going to deal with this? And I went, oh, you're right. I don't know networking. So I wrote down a list of questions and spent 6 months. And then I went on my first interview and poof, I was a senior engineer. It was like, wow, you're really good at this. I'm like, I don't know. I just doing the best I can, just trying to learn.
Yeah. So yeah, it's always interesting. And I'm always curious about how people get into networking, and and how they fall into it. Because it's not until the last 5 to 10 years has it been a career field that people go into. Right.
Yeah.
Like it's not something that people target. And even today, honestly, one of the problems we have in networking is we don't have enough people who know what they're doing.
No, not even close.
We have a lot of people, but they don't know what they're doing.
Yes.
I mean, I hate to be mean, but that's just the reality.
It really isn't. So, I'll give you an example of what we're dealing with. And whether it's a cloud engineer, whether it's a cloud architect, whether it's a network engineer, it's a network architect. It's impossible to hire someone. So Russ, ask me some basic IGP questions, and I'm going to show people how Russ would normally get an answer from 99% of the population. I'm not going to give you the real answer, although maybe I will. But I'm going to give Russ the kind of answers that we get when we interview people.
Oh no!
There's only 3 or 4 basic silly questions.
I don't even know where to start because I never ask IGP questions. Honestly, I always start with something like this. I have 2 hosts. They're connected through a router, and they're all 3 just turned on. Now describe the process that if host A and host B on either side of this router, host A wants to send a packet to host B. Everything's just been turned on. Explain to me the process that takes. Like what am I looking for as a host?
See that. And so first I'm going to show you the kind of answer that Russ would normally get. You just turn them on and they boot and they work.
Yeah, that's right.
Now that's the normal thing. So where Russ and I would be coming from, we're looking to know that the first thing the host has to, when it boots up, needs to activate its network stack and have an IP address obtained by us somehow.
Yeah.
Via DHCP, via its manually side. Then we want that host to see what's in it when it's in its default gateway, for example. And now let's assume the routers come up and the routers boot up, and all of a sudden the routers are running a routing protocol and start exchanging routes. Again, that's something he would need to hear. Now the host on the other side also boots up. It also obtains an IP address. It's on the same subnet as the router. Now host A wants to speak to host B. So it looks in its routing table and it says, it's not on my routing table, but I've got a default gateway. I'm going to say my packet to the router. Now that router is going to proxy ARP that I have the MAC address of the end host. Now once that packet gets to that router, and we could go on, but that's what he wants to hear.
Yeah.
He's looking for someone that knows what the routing protocols are doing, what ARP is doing, which MAC addresses are changing.
Yeah, you don't even have
What
to
he's
use the
normally
right
getting-
names. I don't even care if you know the names of the protocols.
He doesn't care.
What problems need to be solved to get
Yes.
from host A to host B? And like generally speaking, what are those things? How are those things solved? Broadly
Yeah.
speaking, not like
Yeah.
I don't need to know bits and bytes and stuff like that. But if you don't know how to solve that, then you don't know networks, right?
Right.
That's
Because if you can't figure out how hosts communicate, I might even ask, how does TCP set up a connection? And that's very basic.
yeah.
And I might talk about, and I might even say, okay, now let's talk about how TCP does flow control. And then I might say, what are possible opportunities that you can do to potentially throw out certain forms of traffic to prevent congestion at certain points? Now I need a person that understands TCP, understand how the sliding window works, how it's sending things back and forth, understand things like read versus weighted read. And we're not going to ask that. So what happens, we ask these questions and the people know how to configure. They all know how to configure.
Yeah.
They've all done 1,000,001 cloud labs or network clubs, but they don't understand what they're configuring.
Yeah.
And I don't need somebody to configure something that doesn't know what it is. I need the person to know what they're configuring and why they're configuring as an engineer. Or if they're an architect, what is this tech? What is its strengths and weaknesses? How does it integrate with the other tech? What business problems does it actually solve?
Mhm.
And what do I gain by using this tech versus another tech? What I lose? That's architecture thinking. And that's where people go wrong. And whether it's an engineer, and I gave you an engineering example, which Russ was looking for, he's going to get it just works. Or what do you mean? You just turn it on and send a ping and it works. But
Well, we did this once in an interview at Cisco. Don Slice and I did this once in an interview at Cisco. And the person talked for 25 minutes and never once said ARP, never once said IP address, never once gave any of nothing, just was like complete nonsense. And 20 minutes in, Don looked at me and said, "Do you have any idea what he's talking about?" And like, that is just so typical of what you run into. Like, break down the problem, break down the solutions. And again, like you said, architecture level, right? I might say, okay, I have this network today and it's running this, and this, and I want to deploy voice over IP, or I've got to be able to support voice over IP. I don't want you to tell me, well, you've got to configure QoS. Okay, wonderful. That tells me nothing.
No.
What I want to hear you say is something like, okay, if you're going to deploy voice, then you need to have some way to prioritize voice traffic, because voice traffic in real time can only have a very fixed delay and a very fixed jitter characteristics. There's an envelope around voice traffic and the characteristics that are needed. Now we've got to go look at your network and figure out how to accomplish that. That may be traffic steering. That may be quality of service. There might be 1,000 solutions for that. But now I know what my target is. Now I know that you're actually going to be able to think like an architect and say, here's the envelope of problems I need to go solve. Now let's go look at the solutions that we can do.
Yeah, and the implications are when people are doing these network projects and cloud projects, because they think it's going to get them a benefit. If it's only configuring, they're very little utility. Because again, it goes to, I need the doctor to know what kind of medications to prescribe.
Yeah.
For what kind of conditions. I need the architect to do the same thing. I'm not worried about them knowing how to hand you the pill.
Yeah.
That's another person's job. Let's see if we bring in some other questions because these are good ones.
And by the way, this is actually walks into the next question. What advice would you give to kids?
Yes.
But if all you're doing is prescribing or configuring blah or whatever it is, then you might as well be an AI. Okay, what is a large language model really? Again, how does this thing? What does it do? What it does is it consumes all of the human knowledge it can get its hands on in a certain topic, and it summarizes that certain knowledge, that set of human knowledge, into a simple answer. That's what it does. It weights based on what it thinks is expertise. It weights on all this stuff, but that's what it does. Okay.
Yeah.
And that's great. It's a great way to solve specific problems, to answer certain questions. But as far as training you to think or training you to be able to do the same thing the AI is doing, it does none of that stuff. And so if I were to give somebody advice on this, my advice would be don't use it for much other than research. It's a great research tool, and if you use it correctly. So for instance, if I go in and I say, what is the best routing protocol for convergence speed? IGP. And the AI spits back this long answer, right? I don't want to just accept that answer. I actually want to turn around and say, you've told me that ISIS is better than OSPF because of this. All right, now, Mr. AI, flip the question. Tell me where OSPF is better than ISIS, right? Force the AI to summarize alternate solutions, alternate answers, so that you get both sets, so that you don't pick one and just accept what it's saying. That's one thing that I think is very important about this stuff. So don't lose your intellectual virtue. Number one rule for AI, don't lose your intellectual virtue. You've got to learn to think. No substitute for learning to think. So.
And I agree everything with Russ just said, and I'm going to add a couple of things as well. The first is AI will never know what Russ knows. It's never going to be. So people with deep expertise like Russ are still valuable. But we're talking expertise, not technician level stuff. Now, also, if we look at what AI can do and what its implications can do, AI can code, whether that be writing a bash shell script, writing a Linux script, whether a Python script, and not going to be great, but it's better than a junior developer in most cases. It's not good like a professional that's a senior person. So what are the implications of that? The implications are that many of these hands-on junior level careers go away. And long-term, the careers of someone like a Russ, who's a deep expert, become critically required. What else becomes more critically required in today's world where many things can be automated? We need people that have very good interpersonal skills, because at the end of the day, all business is going to be done. A lot of business is going to be done based on relationships. We need people with really good leadership skills, really good management skills, especially if we're going to be dealing with teams that are going to be all over the place, which could potentially happen with technology. We need people with really good presentation skills, really good emotional intelligence. And why is this? Because if some of the tech can be done by itself, why would people still want us? For architects, it's easy because AI just means new jobs for us. Whether it's AI architects, network architects, cloud architects, we've got to build the infrastructure. Because we're still with the people, we're selling, we're bringing in revenue, we're facilitating meetings. So what I would also say is make sure that you emphasize the people skills. So when you have an expertise, and I don't really care what it's in, it could be cloud, it could be AI, it could be networking, but you've got the expertise on how to solve problems and do it from a business perspective. And now you deeply understand whatever the technology is for your career. And now you've got the human skills. You can't be replaced by AI.
Yeah.
You just can't.
Yeah. So one thing that worries me about AI and taking out the middle level jobs is that I got to where I am because I went through the middle level jobs. I don't exactly know how we're going to build careers now when you're going from junior and you have to skip to senior, or you're just going to rely on AI to skip to senior. That worries me a lot in terms of AI. That's something, because like Jose asked down there, how do you keep yourself motivated and disciplined? How do you, when you know that you have to skip this middle level, you've got to learn stuff that's not practical because the AI can do it better than you can until you get your skill set to senior. That's actually a problem that I'm very worried about, that I don't entirely know how to solve at this point.
Yeah, that's interesting. And I think I can tell you that I never had a middle and I never had a lower job in tech. And I'll tell you what I did differently. And I still think it's solvable, but I'm still worried. So when we bring a physician to practice, they're usually pretty good by the time they start. Now they'll spend the rest of their life mastering it, but they're usually pretty good. So for me, I just love networking. So what I really did is, I am not joking when I call the CCIE entry level. That was my first, foray into networking, every single Cisco certification inside of 9 months. But for me, Jose, what helped me is I got done that and I was terrified. Once I realized exactly what I didn't know, and admittedly, I was a little bit of a cuckoo in my youth. I'd read a new book every 3 days. I mean, I would constantly go to everything I could. And I think I went through about 100 books in my first year, maybe more. And each book was trying to get me better. I was going to the right conferences versus the salesy kind of conferences. And it really helped me a lot. I got a lot further than most people actually did. And by the time I got my first job, I was a senior engineer and a lead architect in 3 months because I was panicked of what I didn't know. So if you've got someone like Russ, it doesn't matter where you start him. He's going to get to his goal anyway because he's going to be motivated enough to train it. He's just going to figure out what he needs to know and solve it. The problem is, what about the people that don't do that on their own? How are they going to get there, that don't love it so much that they're literally going to spend 6 hours a day studying on their first job every day for their first 3 years? That's the person that I worry about. And I agree with Russ. For that person, they're going to have to get extremely good training, or they're going to have to be very motivated and doing all kinds of experimentations and learning on their own. And losing that is pretty scary.
Yeah.
It's not everybody's willing to do that or will do that.
Yeah. Now, as far as me personally, if you're asking like, how do I stay motivated? It's actually pretty simple. There's a couple of things. First of all, I got off the treadmill many years ago. Things don't scare me. New protocols, new products, they just don't scare me anymore. It's all good. You can throw just about anything at me and I look at it and go, oh, you want to run 1,000 parallel processors and break the packet apart in the processor. Yeah, we did that at Ericsson. It's called the spider chip.
Yep.
Like, this stuff, I've been around long enough that I kind of can fit things into mental maps. And again, learning to build mental maps gets you off the treadmill. It's a very important skill. But now for me, what motivates me, actually, believe it or not, is a lot of teaching, is seeing the young people come into the career field and going, all right, we've got to get these people up to speed. We've got to do something about this. We're missing a lot of skill sets and we need to do something about this. So where can I jump in? How can I learn things in a way? How can I present things in a way that is going to be easier for people to actually learn the skills they need to get ahead and to do things? So that's actually a lot of my motivation right now. If I didn't teach, I'd probably be half as motivated about the work that I do. Then it becomes a money game because I'm not learning a whole lot of new stuff. It just becomes about making whatever money I can. But throw the teaching element in, teaching at colleges, doing the academy stuff I'm doing, working with Pearson, all that stuff, writing books, whatever. That's much more motivating because now I'm impacting people's lives. And that's really a big thing. So that's kind of the thing.
This is interesting because Russ, we didn't plan our discussion today at all, right?
No.
We just basically shut up at 2 o'clock.
We're going through
and just
our
thought,
copious notes, our 20 pages of notes.
No, we've got no notes here. We're just not prepping. This is just us as standard. So right before this, I had sent Alonzo, Mark, and Chris a notification of someone that just got hired that took our interview training. 2 days ago, there's someone in Dallas that said they just made it into an enterprise architect role, which excited me. Someone in England got their first cloud architect job, and it was their first tech job in their case. So, when I see this, I get motivated. So I kind of did exactly what Russ did. He and I were in the trenches in ways you can't possibly imagine. And I learned really on, wait, this is a new version of this. This is a new version of this. This is a new version of this. And this gets Chris upset when I just show up on a call and I'm like, okay, we're just going to figure it out and we'll go along because Russ and I are busy. But you can see that we've done the same stuff for so long and that we're all coming from that same perspective in that same place. How similar we actually are with near zero planning. I do the same thing with David Lithicum, Deloitte's ex-chief cloud strategist, our AI instructor. We get on, we have no time to actually prepare that either. But it's that. But that's the key. Find what you love. Maybe you love teaching like me. Maybe you like taking the architects and engineers that you work with and getting promoted. That was fun for me. Every big architecture I had, it was like, Mike, okay, build your team. And then I built a team of really smart people that knew all the stuff that I didn't know. And I'd say, okay, where do you want to go? Where do you want to go? Where do you want to go? And the next thing I'm realizing, I'm negotiating with managers. I'm getting them in training. And the next thing I know, they're getting promoted. I love that. So find what makes you happy, Jose.
Yeah.
It's a lot easier, I think, in architecture.
And be a complete person. Be a whole person. Go take classes in philosophy. Go learn stuff. Learn to read. Learn to write. Read books. I don't know. I posted my reading list from this year so far on Twitter, on X, whatever it's called now. And people are like, "Wow, you read 50 books this year?" Like, yeah, I read 50 books every year. Pretty much 50 books every year. And by the way, very few of those are technology books. Like maybe one a year is technology. I almost always hardly ever read anything in technology. So that is, Jose asked another good question, by the way, down there, Mike.
Okay, so let's answer Jose's question, and I know we have to finish up around 4, but great question, Jose. How can a network engineer transition to an enterprise architect role while working 100% remotely, focusing on building the right mindset? So I can give you an example. And I can tell you what I did when I was transitioning to an enterprise architect to put it into context, to realize how easy it would be for you with the right training. Here's what I did. I was working at One Penn Plaza in New York City. I know Russ has made it to the New York City Cisco office. I was actually doing an MBA.
To work in the city, and I parked at One Penn Plaza and walked to the UN building for like 3 years. I did that. So go ahead. Okay. Sorry.
Yeah, I figured you would. So I did that. I was doing an MBA program in Delaware County, Pennsylvania, that was 3 miles from the way to Delaware. Yes. And then I was living in Princeton, New Jersey. So it took me 2 hours to work, 3 hours to go to college, and 1 hour to go home. And what I did, and that was just 3-4 times a week. And what I did was I was still working full-time at Cisco. I was actually working on an RFP that was for the largest voice project for the largest bank in the world at the time. And it was a pretty issue thing. So I was working 60 hours a week. So what did I do? Well, what I did was when I was driving back to class, I would go through an audiobook. And what I would do is because I had 6 hours or 7 hours of driving 3 times a week, that was 3 good audiobooks per week. And I would pick something that was related to something I learned. So I knew what I was learning in my MBA program. And I learned, they're not really talking a lot about marketing or executive this or sales this or this. So I was listening to those other books along the way. And I did that for 2.5 years. And I also went to a lot of executive training and CXO relevancy training and sales training and presentation that Cisco was doing it. So, you can do anything for a short period of time and be okay with it. So if you learn the right skills, you got to take what you learned, Jose, and some of those skills that you learned are going to carry with you because I've spoken to and I know what you know. And then a lot of those other skills, you're just going to have to learn. But it's no big deal. You can do it. You can definitely do it. And that's the key for me. I mean,
I think it's important just to go do it. I think it's important just to do it and just not to be I don't know, just get out there and do it and be curious and be interested and don't take no for an answer and don't take failure for an answer and just go do it. That's to me, like, I don't know how to get beyond that a lot of times.
Yeah. I'm going to pop 2 pieces of text in the chat box. I may have to do it twice. I think it'll help answer some of the other questions. and this is all from RFC 1925. One is the one size never fits all. And I say this because there are literally cloud providers right out there that have architecture frameworks that literally make recommendations without having any idea of the customer's needs. So that's like a surgeon that recommends surgery to everybody they see. But the other one is what Russ and I really talked about, is that every old idea would be proposed again with a different name and a different presentation. That is there. So Jose, I want you to come to the webinar tonight that we're having on how to become an architect. I know we've spoken in the past and you've spoken to my team. Please join us to that webinar. And honestly, that's for anybody that wants to learn how to become an architect. Join the webinar tonight. My team will drop a link for that in there. But were there any last questions, Chris? Otherwise, I'm going to ask Russ for some closing thoughts because he always has so much to share.
I don't see any more
Okay.
in the chat. Yeah.
So let's do this. I'm going to invite everybody to the webinar we have tonight. Russ, any last minute guidance that you could give people on how to build a great architecture career and how to become a leader and,
nothing we haven't already covered pretty much. Read, think, intellectual virtue, learn the underlying technology, stuff like that. Yeah. It's all what we've talked about.
Yeah. So, okay, that's great. And from my perspective, just understand you can do whatever you want. Anything you want, you can do it. What holds people back is themselves. What holds people back is fear. Don't be afraid.
Yeah.
Fear is pain is weakness leaving the body. It's not that hard. Sure, I've had a headache when I've tried to cram too much stuff in my brain. I've had plenty of headaches like that. I know Russ has too, but the point is if you find something that you love and something that's going to make you happy, it's not pain anymore. Don't get me wrong. I actually liked and had fun doing the network engineering thing. I didn't like coming in at 3 o'clock in the morning to fix it when it was broken. And I didn't like, the way I was treated by my management. Oh, It was terrible. So we had our phones, we had our pagers, we were getting the messages on our pagers. It'd be 3 o'clock in the morning, you get woken up and it's like, there's an outage in Sydney. And I'm like, don't we have a TAC in Sydney that can deal with this? Yeah, but they've been messing around with it for 4 hours. They need you to do this. Or what it really was, which actually highlighted something that Russ was saying. Mike, I need you to open the ticket with Cisco because it's going to go to tier 2 because you're the CCIE.
Yeah.
And I'm like, okay. Then we'll get somebody officially very smart to help us. But it's that. But please know you can do anything you want. Anything you want. I'm going to tell you right now, Russ has got some great networking training at rule11.ac. I've seen it. It's pretty awesome. You might want to check it out. His books are all good. I've read many of them throughout my years, and I can recommend them as well. And, Russ, I really want to thank you for sharing your expertise and wisdom with our audience.
Oh, yeah. Well, thanks for having me on. And hopefully we'll be doing a lot more work together with training and stuff like that we can mess around with and figure out how to get stuff done.
I sure hope so. I actually sent you an email yesterday, and I want to definitely speak with you further.
Yeah. I've just been really overwhelmed and haven't answered it yet. That's terrible, but that's what it is. Right now.
Totally fine. I totally get it. Maybe even stick around an extra minute after we stop the recording. Because yes, love to do another show. So maybe we'll have Russ back on another show. Maybe give us a hashtag. We want Russ right. Because I'm okay with it. I'll start it off in the chat box.
Oh my goodness.
Because I love bringing these people that, I've learned from, I admire, and other people that throughout the world that can really help you get to your goals. So, see if you give me some hashtags. Miss Lemon Jammin, that's terrific. And Tyrone, he's over. So, Miss Lemon Jammin, I think she's in Dallas. Tyrone is in Cape Town, South Africa so far. So, we're hitting a pretty big audience over there. So, wonderful. If you've enjoyed, and there you go, Raja Khan. This is what I'm looking for exactly.
Oh my goodness. Okay.
So thank you again, Russ. Maybe stick around 1 or a minute or two after we shut this off, if it's feasible for you.
Yeah.
And take care, everybody. It was so wonderful to see you.